Let's go through these warm-ups. A quadrilateral that is both a rhombus and a rectangle. A square. Second one, a quadrilateral with both pairs of opposite sides parallel. Some of what you're saying is too specific. We don't know anything about the sides being all congruent to each other. We don't know anything about the angles being 90 degrees. If all we know is that opposite sides are parallel, what does that describe? A parallelogram. If it were a rhombus, we would also know that the sides are all four congruent. I'm just going to put the little parallelogram symbol. Number 3, a quadrilateral with exactly one pair of parallel sides. No, a rectangle would have two pairs. A rhombus would have two pairs of parallel sides. If it only has one pair of parallel sides, it is not a parallelogram, which means anything that is a parallelogram is not a possibility. Jaden. Sure. A rhombus would have perpendicular diagonals. That is correct. A rhombus has perpendicular diagonals. If you could not already tell by looking at what our notes look like today, our objective for today is to prove special types of quadrilaterals. We're going to talk about the properties that would prove a quadrilateral to be things like a parallelogram or a rhombus, a rectangle, a square, or a trapezoid. These are all properties that we have already talked about. We have learned 5 ways to prove a quadrilateral is a parallelogram. These are all review. These are things we have talked about, written on the board, been quizzed over. Yes, these should all go in our notes. We know that a quadrilateral is a parallelogram if both pairs of opposite sides are parallel, both pair of opposite sides are congruent, both pair of opposite angles are congruent, if the diagonals bisect each other, or if one pair of opposite sides is parallel, both parallel and congruent. Both of those at the same time. Proving a parallelogram is a rhombus. We only have 2 ways we can do this. First of all, these have to be a parallelogram to begin with. If it's not a parallelogram, this doesn't work. First way would be to have all 4 sides congruent to each other. The other way is to see that the diagonals are perpendicular to each other. We can show one of those 2 things for a parallelogram, then we know that it has to be a rhombus. Next, if we are proving a parallelogram is a rectangle, again, first of all, we've got to know that it's a parallelogram. One way would be to have 4 right angles. Parallelogram with 4 right angles is definitely a rectangle. The other way is to know that the diagonals are congruent to each other. If the diagonals are congruent to each other, it is definitely a rectangle. Next, we've got showing or proving that a parallelogram is a square. We can do that if we know that it's a rectangle, or can show that it's a rectangle and that all the sides are congruent. Or if we know that it's a rhombus and can show that all the angles are right angles. The last way is if we know that the diagonals are both perpendicular and congruent. What this sums up to is that it has to be both a rhombus and a rectangle at the same time. It has to be both a rhombus and a rectangle at the same time. Students, we need to keep our comments to ourselves. If there is exactly one pair of parallel sides, then we know that it is a trapezoid. So these are actually your number 2 on your notes. Do these have to be parallelograms or not? So let's mark them. Okay, on A, would these be a parallelogram?
Yes.
Why? Not all of them.
Most of them.
No. We don't want all 4 of them. Thank you, Martez. Opposite angles are congruent. We don't want all of them to be congruent. If they are all congruent, that's fine. That means that they're 90 degrees each. That's not the case here. For it to be a parallelogram, we just need opposite angles to be congruent. Also, what I noticed when we took a little short quiz over this, a little 5-point quiz, some people were telling me on a problem that would look similar to this that opposite sides were congruent. Is that what's marked in this diagram? No. Okay, so if you told me that sides were congruent on something where you only had angles marked, you would not get those points. Your explanation has to make sense for the diagram that's given. Okay, on letter B, would we have a parallelogram?
No.
Why not?
The size congruent.
Jaden? Opposite sides are not congruent. We have to be specific about if we're talking about opposite or consecutive. Opposite sides are not congruent. So in letter B, the way that I have this marked, consecutive sides are congruent. Like these 2 sides are consecutive, they're next to each other. These 2 are next to each other, they touch. Consecutive means that they're next to each other. All right. On these next examples, so this is actually going back up to your number 1. All that we know about ABCD in general is that it's a quadrilateral. And then each of these letters, A, B, C, D, E, and F, are all giving us different scenarios. So when we move on from scenario A to scenario B, what they told us in A no longer applies. Does that make sense? Okay, so we could draw a quadrilateral. Doesn't really matter how you draw it, it's just got to have 4 sides. Label it A, B, C, and D, and then mark what they tell us. So we know that AB is, what does this symbol mean? Parallel to CD. So we can put the little triangles on it. Those 2 sides are parallel. We also know that AB is equal to, or we could say congruent to CD. Okay, so we have to decide if this is going to be one of our specific types of quadrilaterals. And this is actually the situation that I think we've worked with the least so far. We have one pair of sides that is both parallel and congruent. What did we write that under earlier in these notes? One pair of sides both parallel and congruent. We wrote that under parallelogram. That was the 5th one under parallelogram. That was one of those special situations that we haven't seen yet. So on letter A, we would have a parallelogram. On this next one, we have that AC and BD bisect each other, and that AC is equal to BD. So if we draw our quadrilateral again, A, B, C, D, what types of segments are AC and BD? Those are our diagonals. So this is telling us that our diagonals bisect each other and that they're equal to each other. Diagonals bisect each other and are equal or congruent to each other. What does that fit? I heard one person kind of say it. Angel? A square. Okay, if they bisect each other. Oh, actually, I don't know that I agree with a square. I think a square is close, but I don't think it's quite going to be right. It's more than a parallelogram, less than a square. It's a rectangle. What else would we need? Ooh, let's quiet down. Shh, Jakai. What else would we need to know for it to be a square? What else would have to be true about those diagonals? They would have to form right angles. So the diagonals would have to be perpendicular. If they said perpendicular and equal, then it would definitely be a square. But they always bisect each other in a parallelogram. They're equal to each other in a rectangle. That one's a little bit tricky. If they had also told us that they were perpendicular, then it would have been a square for sure. Are we ready for the next one? All right, on letter C, now we're still talking about those diagonals. If we want to draw our quadrilateral again. If you want, you could draw in your diagonals. They bisect each other, and what does this upside down T mean? And they're perpendicular to each other. So we have right angles, and they bisect each other. Now I want you to be careful on this one. What do we think this one's going to be? What do we think our options are at least?
Square.
Square and a rhombus are both options here because we've got the whole perpendicular part. Okay, they bisect each other. That's going to be true in any parallelogram. So how are we going to decide between a square and a rhombus? Not just the sides, but the diagonals themselves. If this is going to be a square, the diagonals have to be congruent to each other. Are they?
Mm-hmm.
The whole diagonals are congruent to each other? We don't know that. So we can't say that it's a square. We got to go with a rhombus. Okay, we ready for the next one? So on this one, all we know are that the diagonals are perpendicular to each other.
We on D.
We are on letter D. All we know is that the diagonals are perpendicular. Does that fit any of our statements? To think about this for a minute. We know that ABCD is a quadrilateral. Do we know from the get-go that it's going to be a parallelogram? No. So we don't know for sure if it's a parallelogram or not. These last couple ones gave us enough information to know that they were. All this one is saying is that we know the diagonals to be perpendicular. Is that enough information for us to know that this is a parallelogram? No. Okay, so if there's not enough information for us to know it's a parallelogram, we can't take it any further. Having perpendicular diagonals is not enough to know that it's any type of parallelogram. So all we can say is that this is definitely a quadrilateral because that's what they told us in the beginning. So be careful about the information that's given. If they had said that this is a parallelogram from the beginning, then C and D would essentially be the same thing. They'd both be rhombus. Do we have questions about how D is different from letter C? Okay. Letter E. We know that AB is equal to BC is equal to CD is equal to DA. So we know that all the sides are congruent. John? It is not because we don't know anything about the angles. Cade? A rhombus, I would agree. Okay, if we have opposite sides congruent to each other, which we do, opposite sides are congruent, then it has to be a parallelogram. A parallelogram which has all congruent sides is a rhombus. Questions about E? Okay. Next one. Now we've got that AC and BD. Remember, those were our diagonals. Our diagonals bisect each other. They're perpendicular to each other. And we also know that AD and BA are what? What's that last statement tell us? AD and BA are perpendicular. So that means this in here is a right angle. Okay, if the diagonals bisect each other, that's enough for us to know that a quadrilateral is a, starts with a P, parallelogram. So that first statement tells us this is a parallelogram. If it's a parallelogram, then what angle has to be congruent to angle A? The opposite angle, what opposite angle would that be? C. So we know that C is definitely a right angle. What do we know about consecutive angles in a parallelogram? They're supplementary. What angle is supplementary to 90 degrees? 90 degrees. So that means all four of these have to be 90 degrees. So we have all four right angles, and we have that the diagonals are also perpendicular. So what does that tell us? It's a square. If we know all four angles are right angles in a parallelogram, that tells us it's a rectangle. If the diagonals are perpendicular, that tells us it's a rhombus. So if it is both a rectangle and a rhombus, that means it has to be a square. Questions, concerns about that example? There is a lot to it.